Reinforcement bars, commonly known as rebar, are crucial elements in modern construction. Here's a detailed look at both their historical and engineering aspects, historical background, origins and evolution, early use. The concept of reinforcing materials dates back to ancient times. Early builders used techniques that incorporated natural fibers and other materials to enhance the strength of their structures. 19th century innovations. The modern use of reinforcement bars began in the 19th century with the advent of reinforced concrete. The concept of combining steel with concrete to improve tensile strength was pioneered by French engineer Joseph Monnier. In the 1860s, Monnier patented the use of iron bars in concrete to make flower pots and other items. His ideas laid the groundwork for the broader application of this technology. Early 20th century developments. As reinforced concrete gained popularity, various forms of steel reinforcement began to be standardized. The development of different types of rebar, such as deformed bars, helped to improve the bond between steel and concrete. The establishment of industry standards and codes, such as those from the American Concrete Institute (ACI) and similar organizations worldwide, further refined the use of reinforcement bars. Engineering definition, purpose and function. Role in concrete structures. Rebar is used to enhance the tensile strength of concrete structures. Concrete is very strong in compression but relatively weak in tension. By embedding steel bars, which have high tensile strength, engineers can create concrete elements capable of withstanding a wider range of stresses and forces. Types of rebar. Plain bars. These have a smooth surface and are used in less demanding applications. Deformed bars. These have surface ridges or patterns that improve the bond with the surrounding concrete. This type is more commonly used in structural applications. Stainless steel rebar. Used in environments that are highly corrosive, such as marine or chemical exposure, due to its resistance to rust. Epoxy-coated rebar. Provides additional protection against corrosion by applying an epoxy coating to standard steel bars. Material properties. Steel composition. Typically made from carbon steel, which may be alloyed with elements like manganese to enhance its properties. Bonding. The deformations or patterns on the surface of rebar improve the bond between the steel and concrete, ensuring that the two materials work together effectively. Design and installation. Spacing and placement. The spacing, placement, and quantity of rebar are determined based on structural requirements and load considerations. Rebar is placed according to detailed engineering plans and codes to ensure it provides the required support. Concrete cover. The rebar must be embedded in concrete with sufficient cover to protect it from environmental damage and ensure that it is effectively integrated with the concrete. Standards and codes. Different regions have established standards and codes to govern the use of rebar. For example, in the United States, the American Concrete Institute, ACI, provides guidelines, while other countries have their own standards like Eurocode in Europe. Applications. Structural elements. Used in foundations, beams, columns, slabs, and other critical components of buildings and infrastructure. Reinforced concrete pavements. Provides additional strength to roadways, bridges, and other surfaces subject to heavy loads. Reinforcement bars are thus integral to modern construction, combining the compressive strength of concrete with the tensile strength of steel to create durable and resilient structures.
Please like, comment and subscribe on this channel.